right. Welcome, everyone. Thank you for joining us in the Open Security Summit training session today. We are joined by Avi Douglen, and we'll have a session on Introduction to Threat Modeling by Avi Douglen. Okay, so let me start with this welcome slide for you. So what to expect on this? We want you to participate in the discussion. We want you to ask questions, and we want you to care deeply on what the speaker is talking about. And with regard to mutual respect, we expect everyone to respect each other's views and others. And you are free to challenge directly and be solution focused then. The summit welcomes openness, and the sessions will be recorded. It will be video recorded, sometimes live streamed as well, but this time it's not live streamed. It's shared in social media later, in Twitter, YouTube, or LinkedIn. So if you don't want to be identified then, please take personal precautions, such as not activating your video or changing your names to NA as your name during the session. So everything created at the summit is released under a CC or open source license there. So we are here all to collaborate on topics we have chosen as a community, and no one should be discriminated or harassed based on their race, based on your race, based on your gender, based on your age, or religion, or appearance, or being an experience, or anything else. So we are all expected to preserve a certain level of professionalism and respect. And if you feel like you are abused or any kind of abusive behavior against yourself and or anyone else during the summit, please don't hesitate to report it to the organizer or to me or to anyone you know this from the summit, so that it can be handled and prevented from future occurrence. And so our hashtag for today is hashtag OSS2020. And for everyone who's not in the Slack channel yet, I'm going to send you the invite later through chat. All right, welcome, Mr. Avi Douglen, this morning's organizer.
On mute. Morning, everybody. Good afternoon, depending where you come from. Thanks for joining. Give me a moment. I need to share my screen, right? Where is the controls for that? There we go. Share screen. All right. All right, so I'm going to be giving you a pretty quick, high-level introduction to threat modeling, explaining what it is, and you know, if you're not familiar with it at all, it's basically a way to do security design. Before we get started, I do want to point out that this is a really, really introduction level, even pre-101 type of training right now. So if you have a lot of experience with threat modeling, or you know what threat modeling is, you might be wasting your time here, honestly. I will give some my own perspective, and there are some differences from the way some other people do it. But the point here is to give you the basic grounding for what threat modeling is, the common language, the tools, the common approaches that we usually use. The main purpose, of course, is to be prepared for the summit sessions around threat modeling, so you can come in and you know what you're getting into and know what threat modeling is. But again, if you have experience doing threat modeling, I'm probably not going to be adding a lot to you here. So the first part, I'm going to be explaining what threat modeling is and how to do it and the basics and the way everybody does it. I will, towards the end, get to my own different way of doing things, of getting developers involved in doing threat modeling, giving them more tools to do it as part of their agile workflow or CI/CD or whatever kind of lightweight threat model will fit their workflow. As far as that goes, you know, threat modeling is not new. It's been around for a long time. But as far as it's not really a science yet, there are still widely varying approaches to doing threat modeling. And especially when it comes to the more agile approaches, the more lightweight approaches, there's really a lot of difference of opinion, a lot of different voices. And you know what? There are a lot of really good ideas of way to do that. So I'm going to show you my way. I'll explain some of my issues with the more heavyweight approach to threat modeling, which is the correct way to do it, but it's really hard to get that correct way into a lightweight development workflow without enough security people, right? All right, so let me, I see there's some questions. I'm gonna try and keep an eye on the chat, but it's a different screen here, so if you do have any questions, feel free to unmute and jump in. You could go ahead and just write it in the chat and I'll notice it eventually, or Alona can call it out to me. All right, here we go. Okay, so that's kind of a preface to the introduction. Let me introduce myself, right? My name is Avi Douglen. I have a Tigger face bouncing around the internet. That's my internet face. You can find me on Twitter, SecTigger. That's my email if you want to reach out. If we ever do wind up ever meeting in real life, the important thing you'll want to know about me is that I like my whiskey smoky, I like my beer stout, I like my coffee black. If you ever want to buy me a drink, I appreciate that. I also have 5 kids at home, so it's very useful. So I run software security consulting at a small agency called Bounce Security. We do research, development, architecture, everything around software security. Okay. I'm also a startup advisor at the Labs O2 incubator for the OurCrowd family of VC. I want to hide. Oh. Zoom tends to be annoying. All right. I am one of the leaders of the OWASP Israel chapter. Most years we have a really great AppSec Israel free conference around September. This year it's probably going to be a bit different. We were originally expecting around 900, 950 people coming to the conference this year. 2-day conference, 1-day full conference talks, another day of secure coding training for developers. Hopefully next year we'll get back to it. I don't know if we're doing it virtual this year. No, I don't think anybody knows at this point. I'm also one of the leaders of the threat modeling project. Hopefully next week in the summit, we'll have a couple of sessions to develop what that really means, what it really does. So far, it's not much. By the way, I'm also one of the community moderators on Security Stack Exchange. If you're not familiar with that, it's exactly like Stack Overflow that everybody knows, just about security questions. All right, so it's another great resource to have. So I'm gonna let you know how I'm structuring this session, and I like to keep things simple. First of all, I'm gonna say why. I'm gonna try and explain why you should be interested in doing threat modeling, why it's important. I'm gonna explain what threat modeling is, and I'm gonna talk about how to do threat modeling. I'm also towards the end going to talk about who should be doing threat modeling, and just to put the pin in it and wrap it up, I'm also going to talk about when we should be doing threat modeling. Now, this is not going to be direct order of the talk, but these are the topics that I'm going to be covering. Like I said, I like to keep it simple. All right, so the real question is threat modeling, right? How do we go about designing our application for security? And I'm sure a lot of you have been in meetings and arguments, whether between security and development people or product or managers, who say like, no, we can't do that. We don't have time for that. Well, we have to do it because it's security, right? And then you always have that kind of push and pull and argument, and nobody has the right answer for that. Of basically, how secure is secure enough? How do you know that this is what you need to be investing in? Whether it's developer time or QA time or hiring external consultants or buying products or services. How do you know that this is the right amount of security we need, right? Because nobody wants to be spending too much on security. You wind up wasting time, resources, and there's no real value, supposedly, right? There's ostensibly no real value in having security you don't need. On the other hand, it's pretty obvious that if you don't spend enough on security, you're gonna get breached or fined. And if you don't think it can be worse than being breached, just talk to British Airways, how to pay several 600 million pounds in fines recently for GDPR non-compliance. So, it's always a question of, do we do enough? Do we do too much? And everybody's just pulling in their own direction. And unless you have some basis to prove that this is the right thing that we need to be doing, everybody's just, pulling their own opinion. And there's no real metric for knowing if it's the right amount of security. Do we need to be doing more or less? Worse than that, very often we wind up wasting too much time and money and resources on security, and then we still get breached anyway. It sounds crazy, but you can be wasting security and still not be getting the right amount of protection that you need. Part of it is relying on these generic best practices, so to speak, right? The problem with best practices is that they're very generic. They have no context. And you can't apply generic rules to what makes sense for your business, for your application, for your product, for your software. And it comes back to the fact that we like to feel that security is kind of a simple binary metric, kind of like ketchup. More security for those that like ketchup on their fries, and less security for those that don't. And if only we could just magically find that one perfect amount of security, we can just easily calibrate to that one magic amount of security and be able to know that we're not spending too much and we're not wasting and we're not going to be attacked. But the truth is that security investment is not a binary metric. It really looks kind of more like this. All right. There's a lot of complexity in there, a lot of nooks and crannies and peaks. And it's not just a simple yes or no, more or less. It's a question of where you put your resources. It's a question of where we invest in security. Anybody recognize, quick show of hands, anybody recognize this picture? Anybody familiar with that? This is a picture of a World War II aircraft. I believe it was a bomber. And as I'm sure most of you know, during World War II, the bombing effort was a big part of the Allied defense, and a lot of the planes got shut down, and they needed to figure out how to protect it, and they needed to protect their aircraft. And I think it was something like 25% of planes didn't come back from each run. So they said, okay, we need to add more armor onto our airplanes. Well, obviously you can't put armor on the entire airplane. You can't fly a tank. That's too slow. They'll get shot down more often. Cost too much. In both in armor and in fuel. You can't carry more bombs. You basically can't. You can't put armor on the whole thing. So they said, you know what? Let's do some statistics. Let's do some research. And after every bombing run, when the planes come back, let's mark down where the planes get shot. And each one of these red dots on the planes is a statistical amount that the planes that came back had bullet holes there or flak. And they basically collected over a certain period of time. They started measuring and collecting where the planes were getting shot. And they said, okay, where these red dots are, that's where I'm going to go and add more armor. And we're going to protect the planes in the places where they get shot. Makes sense, right? Anybody want to jump in with the problem with that approach?
Wait.
Oh.
Yeah, go ahead. Go ahead, Carl. The problem, of course, is survivor's bias. One of the statisticians pointed out, Abraham Welch, I think was his name. I'm probably remembering that wrong. He pointed out that they're only measuring the planes that came back. They have no information at all on the planes that crashed and were shot down and didn't come back. And that's actually what you care about. You don't care about a bullet hole. You care about the plane not coming back, because that's what affects your bottom line, right? That's what affects everything. A bullet hole you can fix. As long as you come back, it's fine. And then he realized, hang on a second, statistically, the amount of anti-aircraft fire means that planes should be hit all over. There should be red dots all over the plane. And the very fact that there's a whole bunch of areas here that don't have red dots probably means, and he did some research on this, it means that when the plane gets hit in those spots, that's when it doesn't come back. And thanks to that fellow, they realized that where they need to add the armor is exactly in the spots that the planes don't get hit. Because imagine if, sorry, the mouse. Imagine if the plane gets shot over, gets the entire tail blown off, or when the engine's blown off, or in the cockpit. Obviously, that's where the plane is not going to survive. And since what they really need to care about, the bottom line, is having the planes come back so they could do another run after that and have the pilot survive and be able to do another run and another run. What they really care about is not where the attacks are, but how the attacks actually affect the functioning of the plane. And this is exactly the concept that threat modeling wants to introduce. It's not enough just to collect statistics of, okay, we had this many kinds of port scans and whatnot, but if you really understand the function of your software, you understand how the attacks affect your software, then we protect against them a whole lot better. Does that make sense? And then you have to really ask yourself, so what does secure even mean? Does it mean that the plane isn't getting shot, or that the plane comes back? Obviously, the plane getting shot isn't the main part of the problem. But then we need to ask ourselves also, so does secure mean we're not getting hacked? We're not getting attacked? Or maybe we're getting attacked, we're not breached? Another question we need to ask ourselves, what is it we're protecting, right? Do we care about protecting the data? Do we care about the financial value? Do we care about the reputation? Maybe we should be worrying about how we're being attacked. You know, just put out some monitors, do some statistics, do some threat intel, and understand what attackers are using nowadays. And maybe that's what I need to care about. Or maybe I need to care about who my attackers are. I mean, sure, that's important. And there's a world of difference if a 15-year-old in their basement is attacking you versus the NSA. Well, depends who the 15-year-old is, they might be more dangerous. But something like that might be an aspect of that also. Or more importantly, even why are they targeting you? Is it just because you're a target of opportunity, you happen to be there? Or is it because you have a massive red circle on your back? Or is it for some political reason? Or is it because they know they can gain millions and millions of dollars from you if they manage to reach, and therefore they're going to be spending a whole lot more time and effort on you? Now the problem is that any one of these could possibly be subjectively true, but none of these give the whole picture. None of these actually inform what you should be doing. They're not actionable. It doesn't help you understand what your actual levels of security is and what you need to be investing in. So what threat modeling actually does and why it's so important, right, is that all software will have vulnerabilities, right? Statistics, depending on who's doing the statistics, probably every component has between 60 to 80% of components will have an exploitable vulnerability. Take that into account. Obviously, you have more components, more code, more bugs, more vulnerabilities. In 2020, customers are starting to demanding to not just have security, but to know what that security is, right? Consumers will often forget about it. Sometimes it'll be in the news. A couple months ago, Zoom had some really bad press. A few weeks later, it recovered, and most users have come back to them. If your customers are corporate customers, they usually have their own regulations, their own processes, their own requirements. So you want to be able to show not just what your security is, but also sometimes you want to be saying why you're not protecting it against something. And anyway, you want to be sharing, you want to have a shared model of what your security is. These are the risks that I care about, and these are the ones that I don't. And that's also okay if you have a reason for it. obviously, if you have a secure design, that's going to be a more secure product. It's also a lot more efficient to find security issues in a design or an architecture before you start writing hundreds of millions of lines of code. Okay? And you have that shared understanding, that shared model of we all see the system in the same way. You might be familiar with the old metaphor of four blind people describing the elephant in the room. Okay, one of them says, "Oh, it's long and hairy," and he sees the tail. Another one, "What are you talking about? It's solid and it's round." Another one feels the ear and it's floppy, and they're all describing something completely different. They think they're talking about some different things, but obviously this elephant has different aspects to it, and you need to have a shared model of a full view of the entire system. And then it goes back to, not wasting time on building security features that you don't need. And then because you didn't fix the things that you do need, then after the fact, while you might have gotten attacked, you might have to roll back and starting to layer on defenses after the fact. And you start wasting a lot of time and it's inefficient all around. Anybody involved in R&D or software development, whether they're programmers or program managers or R&D managers or QA, DevOps, let alone security people, have to take this into account. Now, it's not that it's the only job, obviously. You have a lot of other stuff you need to do. You need to be writing code. You need to be pushing out features, builds, whatever. But it is absolutely an essential non-functional requirement. Okay? And as I said, it's a lot more efficient to do a little bit more work now instead of a lot more work later. And threat modeling comes back to answering the question, which is the security we need to be working on? What is absolutely vital to our bottom line? And using threat modeling as part of the development process allows you to be proactively own your security, right? You take your product and we say, okay, these are the things that we care about. These are the things that are going to now be features as part of our product, and we're going to protect those features. And again, I keep coming back to efficient. Yes, threat modeling can be a lot of work, but it's a lot more work to not do threat modeling. Now, I want to ask a quick question before I continue. You could either drop off a mute or just quick show of hands in Zoom. How many folks here are coming from the development background? Programmers, QA, DevOps, as opposed to the security side of the house? Nope. Okay, quick show of hands if you come from the developer side. Anybody? Is everybody here from security? Oh, some comments in chat. Let me read that out a second. Where did that go? Governance. Okay, that's a good side. Threat modeling will definitely help with that. Both sides is good. Software dev and an AV company. Okay, that's good. Now, interestingly, being a software developer in a security company, working on a security product, can often cause some kind of dissonance, right? Because on the one hand, you're working on a security product. On the other hand, like any developer, even if it's a security product, very often people are not paying for security of the security product. The difference between secure features and security features, right? They're paying for the security features. They don't care if it's secure or not. So sometimes, I don't know if you've, Connor, I don't know if you've had that dissonance, but I've been there, I've seen that. It does give a good, should give a better background, a better basis to make the case for we need to spend more time on secure features. But threat modeling will absolutely help with that also. So I see a few more governance and a whole bunch of both, so that's interesting. Yes, for sure. You've had that exploits in our code base affect reputation, of course. Yeah. I mean, there's a very well-known web application firewall that had a cross-site scripting in their admin interface for years and didn't affect them one bit. There's a world where they say, oh, just protect it with our own WAF. End of story. I don't need to worry about secure coding. So that's the kind of dissonance that I'm talking about. All right. So let me explain a little bit more about the threat modeling approach. Okay. What threat modeling basically is, it's a structured process, and there's a few different structures: more heavyweight, more lightweight, more formal, less formal. But it has to have some structure to do security analysis of the software, usually based on the design, the different parts of the design, the different components, and we're going to get into that in detail. But it does give you like a framework to start thinking about the possible threats, a framework or an outline to start understanding how security issues could affect your software and the different parts of your software. And once you understand all those threats, you understand how they affect your system and affect your bottom line, it will actually allow you to start prioritizing accordingly, because you'll really understand the level of risk. It might be a question of, yes, this can cause a lot of damage, but it's really incredibly hard for an attacker to exploit that. They already need to have a certain level of privilege, and they need to be able to, and so on, and we'll discover it. So that obviously would lower the risk. And you could go the other way also and say, sure, it's very easy, but it's just a nuisance attack, and I don't really care about it, so I'm not going to spend a lot of time on it until it starts affecting me in a way that I need to care about. Because threat modeling always needs to come back to the bottom line. If threat modeling is only a technical exercise, then we're probably missing something important. Okay? And risk, when I say risk, I mean business risk. It comes back, it's the correlation between technical and business risk. So really, at a very high level, that's what threat modeling is. It's a structured framework to do security analysis of your system design. It's a whole lot of words to say the same thing. And there are a lot of, as I've said a few times, there are a lot of different approaches, and there's no one way that is the correct way. There's a few ways that are wrong, but there's no one way that is solely correct. There's a lot of different approaches that are perfectly valid. And I always say, if you have an approach that is working for you and giving you good results, that's great. That's fantastic. That's all you want. Because the entire purpose of threat modeling is not to generate all these big documentation and reams and compliance and whatnot. The entire purpose of threat modeling is to produce more secure software. There's another aspect to that, is to know how secure you are, right? And this connects to a few folks said they're in governance. And threat modeling will absolutely give you the basis for that. But whatever approach you're using, whatever fits for your architecture and your teams and your technology and your way of working, your workflows, any one of these are fine. There's software-centric approaches that describe the software and start from the software design side. There's asset-centric, which focuses on your database and your records and understanding who can get access to that and in what ways data gets into that and so forth. There's attacker-centric, which is kind of more of a black box approach. Higher end penetration testers and red teams will absolutely be doing that to understand what an attacker can or should be able to approach and do. And there's a few methodologies around that, and that's great. There's what's known as a risk-based approach, and I'm going to give you an example of that, which is really great, especially for the governance folks. It's great for the more corporate enterprises, and it's less on the technical developer side. But again, there's different ways you could take that. And then there's what I personally call a value-driven approach, and I'm going to explain more of that later. But that focuses, as I mentioned, if all these approaches wind up including some aspect of the business value, the business risk here, how much it affects your bottom line. So what I call a value-driven approach, it starts with that and lets that be the scoping of what I need to be caring about. And I'll explain more in detail in a bit. I like the four-question framework that Adam Shostak, he's the god. You might not like his methodology. So some people don't like his methodologies. I do. But either way, he's kind of the godfather of modern threat modeling. Literally wrote a book on it back when he was at Microsoft. And he'll probably be at the summit next week also, at least some of the sessions. And he says, whatever methodology you're using, you basically have to come back and answer these 4 questions. All right, number 1, what are we building? What are we working on? Okay, this might be the software design. This might be if you're modeling a process or a framework, whatever you're working on. That's number 1. You need to really understand how that's constructed, the design, the interactions between components or people or whatever. Number 2, what can go wrong? These are obviously the threats, and there's a few different approaches to this. I'll mention this in a moment. Now notice, like a lot of times threat modeling is, let's produce a list of threats and we're done, let's go home. But that's only step number 2. That's only the second question. That's not enough. One of the most important things we need to be asking ourselves is, what are we going to do about it? Great, we found a whole list of threats. How are we going to fix that or prevent it, or at least minimize the damage, right? That's number 3. And number 4, like any kind of process of software development, did we do a good job? Right? We got to review, and did we build the right threat model? Did we find all the right threats? Do we still understand the system correctly? Did we solve all the right? Do we solve all the threats that we found? Did we solve the right threats? Did we implement it? And so on. So any threat modeling approach you're using, you need to come back to these 4 questions. Again, what are we building? What can go wrong? What are we going to do about it? And did we do a good job? Somebody mentioned that Adam also uses the plane analogy. I think I can take partial credit for him using that. I'm not sure, but I think so. Yeah, but it's a great example because it's so visual. Very often, threat modeling, when doing threat modeling, we're going to use a data flow diagram. If you're not familiar with the data flow diagram, this is kind of what it looks like. You got your circles for your processes, you got your double lines for data stores or databases or maybe a file. And then, of course, you have all these data flows. And this is the focus of the data flow diagram. Understand how data comes into the system and where it goes between components, where it winds up, who has access to it. So there's kind of a combination between asset-focused and software-focused approach. But one of the big things we need to do on this DFD, this data flow diagram, is focusing on external entities. In this case, we have a user and sending a data flow requesting withdrawal from the bank account. And this data flow goes across a trust boundary. Now, sometimes you'll have a few components inside a trust boundary, and they may trust each other because they're running as part of the same server or whatever. But very often we want to start with any data flow that crosses the trust boundary because it's obviously untrusted. We can't trust it. We need to do a lot more work on that. And even if we try and authenticate it and validate it and whatnot, there might be additional possible attacks or threats that we haven't considered until we do. So, so there's other diagrams you could use and there's other approaches. Best ways to have something visual. Because when you have something visual, whether it's on screen or on a whiteboard, you can go and work on that and you can discuss different parts of it and you can each get a shared vision of the system. So the process that we would do is kind of a 4-step process plus a pre-step. So I call this step 0. Number 1 is the scoping. Okay, you need to be able to scope out the threat model that we're working on now. Now, the reason that this is super important is because you can't build a monolithic threat model for your entire application all at once, unless it's a trivial application. So you need to be very, very clear and specific about what you're modeling right now, which part of the system. Excuse me, right? Which part of the system, which components are in your scope right now. You might not want to go too deep because that's the architecture, and you'll do a separate model for the architecture. We're just modeling a specific feature right now. Or maybe you have external services that you're calling a third party, and you don't need to model the threat of that. You just need to understand the interaction. So you need to be very specific. Otherwise, you're going to fall into one of the big pitfalls of doing threat modeling, which is digging far too deep, just getting sucked into the rabbit hole, and never getting out, because you know what? There's always more to talk about. There's always more to dig. There's always more to find. So you need to be able to have a limit to your model. And this is kind of a pre-step. Before you start doing the threat modeling, before you get everybody in the room and start having that meeting, you need to be very clear on what our scope is. The other part of the scope, by the way, is you might say there are certain things that I don't care about now. For example, right now, I don't care about the NSA trying to hack me, okay? Or I don't care about the Chinese army or Mossad trying to hack me. That's not in my scope right now. I might want to document that and come back to that later. But right now, anything that comes back to you need to be the NSA to do this, to exploit this threat, not interested. I don't want to hear about that right now. I don't want to take time out of my day to take care of that. We'll document it, put it down the line. We might revisit that, again, depending on your context, depending on the business context of what you're working on. Obviously, if you're developing WhatsApp, or Facebook Messenger or anything like that, might be very interesting. If you are developing a cat blog to share pictures of your sister's cat, not going to be so interesting. You might also say, well, denial of service is not of interest to me right now. Again, you know, if it's a cat blog, I don't really care about it. And again, depending on context. So you can scope things in, you can scope things out before you start. Now, the four main steps of threat modeling. I'm going to go into a little bit of detail of this after I give you the overview. Number one is to decompose the application, to understand the different components, the data flows. And, you know, data flow diagram is really fantastic for this. What's good about data flow diagrams, and I'll show you a few examples in a bit, but what's really useful about data flow diagrams is that they're very, very simple to just draw up on a whiteboard. Or, you know, there's a few different apps that, you know, everybody's working remote now. There's a few nice apps that you can use to just collaboratively draw a very simple DFD together. It doesn't need to be complicated. You just need to break it out for any flow between the components. You need to understand the logical view. And you need to be able to float out assumptions, okay? If I assume something works a different way than that needs a certain way, that should be reflected on the whiteboard, so that somebody else can come and say, well, no, actually, it works in a different way. Or, no, we never actually implemented that. Or, we should probably go ahead and check that that's the way it really does. So again, this comes back to having that shared vision of how the application works. It's basically the architecture. Now, if you don't have a DFD, you can use something else. I mean, it's perfectly fine to use a different type of diagram, whatever you have, whether it's swim lanes or process diagrams or mappings of different sorts. And you can absolutely do a threat model and a different diagram. If you have nothing, a DFD is probably the easiest way to start and fleshing that out and be able to understand the interactions in the different parts and the different flows. Step two is to identify the threats. Okay? Understand the different ways an attacker can attack a certain interface or abuse a component or take over some kind of interaction, right? This is kind of the important part, and I'll show you some techniques for this also. And there's a lot of different techniques. Once we understand the threats, we've cataloged them, we've prioritized them, and it's kind of important to first focus on the threats, not get sucked into, oh, we could fix it that way or that. During the threat modeling, we're just brainstorming to find the threats. We'll worry about fixing it later. And that's step number three, to understand which countermeasures we need to implement and work on. Very often, these are pretty straightforward. Yeah, okay, I need to strengthen my authentication mechanism so there's no brute force. Obviously, I know I need a strong password policy and I need a lockout mechanism on wrong password guesses. I don't need to go into a lot of detail to prevent a brute force threat of a brute force attack. Sometimes it can get more complicated. There are certain things that you need to go into a lot more detail and understand if it's a more complicated threat or more complicated implementation. So sometimes it is more, but either way, whatever the threats are, you need to agree which ones you're fixing and how. Okay? And number four, after we've done all this, we need to now analyze everything we did. Number one, by the time we finish this process, is our understanding of the system still the same? Or do we need to now change the diagram? This very often happens as we're discussing possible threats. I was like, oh, wait a second, that component is actually two different components. Or it actually calls a third party to do this functionality. And you understand that you actually need to change the diagram as you go, and that's really fine at each step to go back. But at the phase 4, when we're analyzing the result, we want to make sure that the diagram is still correct, our understanding is still up to date. And then we ask ourselves, well, did we find all the threats? Or did we have a blind spot that we didn't look at a certain component, or we didn't consider a certain type of attack? And you need to see, that you have a good picture. But then also you want to be asking yourself, well, assuming that we defined countermeasures or mitigation for the riskiest items, did you do it in a full way? Is there still residual risk? Or was it only a partial fix? Or maybe it's a complete fix? And now maybe these countermeasures that you're now designing on the fly might now have introduced additional threats. For example, if you just designed a lockout mechanism to prevent brute force attacks, you just introduced a denial of service threat. Now, obviously, most of us know that we need to have a timed unlock or some other mechanism to prevent that. But that's a good example of, by introducing a countermeasure for threat A, I just created threat B that I didn't have before. So that's kind of an overview of the process that I'm going to show you. There are other processes you can break down in different ways. Unsurprisingly, this pretty much matches Adam's 4-question framework, right? What are we building? That's the application. What can go wrong? That's the threats. What are we going to do about it? Countermeasures. Did we do a good job? Analyze the result. It's not surprising that it goes that way because it's very straightforward. Again, there are more formal, more detailed methodologies that you could consider if you want. But this is a decent basic outline for things that you need, almost a minimal level of things that you need to be dealing with. Now, each one of these phases, there's not one overarching methodology that you need to use to do this whole process. You could swap different things, different techniques in and out for each of these steps. For example, I'm going to show you to phase 2 to identify the threats. I'm going to show you stride, and I'll explain that in a moment. But you could easily use something else, like the attack framework for MITRE. You can use threat intel. You can break this out into a whole lot of more detail. Instead of decomposing the application with a DFD, you can use any other kind of diagram. You could do this in a lot of different ways. Adam also talked about using this as building blocks. And there's something that I build also. Each of these steps is its own building block. You can use it in a lot of different ways, and you can plug each step into a different technique down the line, and anything you do there is fine. While I take a drink, anybody have any questions? So one of the most common ways to identify the threats, phase 2, right? Once we've done our diagram and we understand how the system works, is what's called stride, or stride per element. Some people know it as the Microsoft model. What stride is a mnemonic, right? Spoofing, tampering, repudiation, information disclosure, denial of service, obligation, privileges. Yes, I can say that faster, but I'm going to also go into that in a bit more detail. But before I do, what stride is, it's not a categorization of threats. It's a brainstorming device. What we're going to do is we're going to go into each of these categories of possible attacker goals and understand what possible threats might fit in here, and come up and use this to start asking questions of ourselves and of each other and of the system, and try and come up with additional threats in that broad set of stride, right? Now, very often, another pitfall that I see very often is people finding the threat and then start arguing about, is it a spoofing threat or a tampering threat? What kind of threat is it? And it doesn't matter. There's even some tools that require you, threat modeling tools, when you find a threat, you have to categorize it. You have to label it as what stride category it is, which is besides the point. Because the whole point of stride is brainstorming, to come up with new ideas for more threats. So let's talk about this for just a moment. Let's go through the different stride categories. So spoofing is around identity, pretending to be somebody or not. This could be a user claiming to be a different user. This could be a web server pretending to be a different web server, putting up a bogus server and intercepting requests. This could be a third-party service, right? There's a lot of different ways to spoof identity. You could spoof a device and so on. It all comes back to identity of whatever entity it is, whether it's users, systems, servers, devices, and so on. All about identity. Tampering is changing data you should not have access to change, right? Whether it's in the database or in a file or in another user's session, local storage or cookie, or obviously on the network. Okay, anything being transferred might also be tampered with if it's not changed. Any data or code. Code is also, when it's stored as a file, that's also kind of data. And I might be able to tamper with the code of the running application. That's another form of tampering threat that needs to be considered. So there's a lot of different types of tampering around anything that the attacker should not have access to. Repudiation is claiming you didn't do something that you ostensibly did. For example, if I get the bank report and the bank says that I just transferred $1,000 out of my account into into a third-party account, and I say, no, wait, it wasn't me, I didn't do it, and then the bank is supposed to go ahead and prove that I did. I just heard recently somebody had that happen to them in PayPal. Somebody hacked their account, transferred money out of their PayPal account, and now PayPal was saying, no, it was you. And they say, no, it wasn't me. So, proper functioning bank should have some kind of control around repudiation. Again, claiming you didn't do something, whether you did or not, right? Information disclosure is reading data that you shouldn't have access to, kind of the corollary to tampering. Again, this could be in a database, this could be in a file on the server, this could be on another user's session or cookie or whatever. It could, of course, be on the network. It could be in memory. Wherever this is, getting access to reading data you shouldn't have access to. Denial of service is blocking access from users that should have access. And this could be complete shutting down the server, crashing it, nobody has access. This could be on a specific user. That user, I'm now locking that user's account and they cannot log in. This might be on special users, locking the admin account, for example. And there's plenty of denial of service attacks that degrade service. They don't crash the service, they don't lock anybody out, but they just flood it so much that regular users no longer have the option to use it properly. And then, of course, there's elevation of privileges, which is basically doing anything you're not supposed to do, right? Leave a 15-year-old home alone, and you'll find out a whole bunch of things that you didn't even think about before. So that's the stride, right? Elevation of privileges sometimes include some of the other threats, but it also includes a lot of other things that you should not be allowed to do. So the way we use this, again, this is a mnemonic. It's a brainstorming device to help you come up with questions and understand what else to be able to use. What other questions you need to be asking, how else the attacker could be using your components and being able to misuse them or find additional threats. I see a quick question here. Do I use the elevation of privilege card game in practice? Oh, I love that question. I actually have a deck here on my shelf. Honestly, I've only been able to actually use it in training sessions. All right, I do like a 2-day training session, and we'll use the cards in between. Those of you not familiar with the game, again, this is Adam Shostak developed the game. He actually is game designer on his bio now. And it's a typical card game, right? That you play cards, you take the higher card in the suite, and the way to play a card is with a given system design or a DFD, you play a card that has a certain threat on it. And you can only play the card if you come up with an example of that threat or how to apply that threat to the system. And then that allows you to take the trick and move on to the next thing. So no, I've not actually ever properly used this in a threat modeling session. I've heard of a few folks that have done that. Maybe I've just not been lucky with the card games. I don't know. Actually, I've seen a few examples. I don't remember the links of the card game online. There's a website that you could play remotely with each other. It's not the same thing as holding a card in hand, but you can play it over the web, and it helps. And what I like about this is that if you play the game on a real system, it does challenge a lot of people to spend more time to think about additional threats and to get more creative, right? And it basically gamifies people into coming up with additional threats, which is a really cool idea in principle. Again, I haven't had luck doing it. You know, if anybody here does have that, then I'd love to hear. I've seen a few more questions. I'm going to take a break and read these out. Okay, here's a long one. So Sebastian asks, I often have the fear to miss something when doing threat modeling. Okay, so right there, I'm going to stop for a moment. And the fear to miss something is absolutely another one of the common pitfalls. A lot of people say I can't do threat modeling because I don't know enough of the attacks. I'm not that familiar. I'm not going to find something. And that's okay. Adam likes to quote George Box, and I like to misquote Adam. So Adam doesn't say, all threat models are wrong, some are useful. The original quote is all models are wrong. All threat models are wrong, some are useful, and it's okay if it's not complete. Yes, there are some methodologies that are more comprehensive and kind of expect or even demand finding everything. But I always say, if it helps you fix even one threat that you didn't have fixed before and you have prevented one vulnerability in your code, that's already a better situation. You know, I don't think you should spend 3 months to come up with one threat, but there is a happy medium in between and finding a safe way. And I'm going to go into this in a lot more detail because my approach is a lot more lightweight, a lot less formal, and really leans into the not finding everything. But you do write some more stuff. Let me see what you wrote here. So Stride is good for brainstorming, correct. But as I follow, a lot of implicit knowledge is required to memorize in which forms actually spoofing and tampering can materialize. So interestingly enough, this actually takes me back to the Elevation Privileges card game. So not using it as a card game, but using it as a few ideas, not playing the game, but just using the cards as kind of a reference to some questions you might be asking, that can help you come up with ideas, okay? And there's a few tools out there that will do the same thing, all right? There's some commercial tools like Irius Risk, and there's the Microsoft Threat Modeling tool, which for a given category will just throw up a whole bunch of questions for every component and try to ask, and you need to be able to fill that. Now, you're absolutely right. There is a lot of implicit knowledge here because especially developers and, you know, governance folk, I'm sure also, if you're not actively involved with security research or red teaming and things like that, you're not going to know all the possible attacks. And that's where a lot of this comes in handy, the different methodologies. So there are some methodologies that will help fill that in. You might want to, and I say it's really okay to not have all of that, to have some is also okay. But it definitely does make sense to have an SME, right? A subject matter expert in the room with you. As you're doing a threat modeling exercise, it makes sense to have a security guy in there, security girl in there, security person, to do that, that kind of, they might not know the system as well as you do, but they're more familiar with possible attacks and the part that can go wrong. Additional sources are very good. I'm going to mention this in a bit. So Sebastian mentions ASVS is a good catalog of things that need to be tested for or controls that need to be in place. And that's definitely something that you can look up with. NIST SB 853 controls. Yeah, I mean, so there's a lot of guidance that you can use. I've seen a lot of people, Brooke Schoenfeld likes to use the attack framework. I've heard him talk about it. The attack framework, if you're not familiar, is kind of a category, a catalog of all common attack techniques, broken down to different goals and things like that. And that is actually a nice resource to use for possible attacks. And you can use this in combination with Stride. You know, we're looking for what other spoofing attacks are there, or how can an attacker implement this threat, and then you can go ahead and look up elsewhere, like attack or CWE if you're more familiar with it, and so on. I'll not forget anything. Are there other sources, like apparently this card game, to be taken into consideration? And yes, there are plenty, and I don't think there's one that is the absolute correct one, because the way I see it, if it's comprehensive, it's got to be too much to use on the fly during a session, right? If it's not comprehensive, then it's still going to be missing a lot. So it's really hard to find the correct balance and the right trade-off there, and there is no one correct answer. You know, it really comes back to context. It comes back to what fits your team, your product, your business. Again, sometimes just simply having a security person in the room might be the best solution for that. Somebody that is familiar with all the attacks. And again, they don't need to be a software person. They could just be a red teamer or a pen tester or an attack person that is familiar with all the offensive techniques of ways of breaking things. And that might be the best trade-off on resources. Because again, you know, the trade-off being between the just-in-time amount of information. Sebastian, is that a good, complicated set of answers for you? Okay, I'm gonna scroll down. Let's see if there's more questions here. Okay. InfoSec Minion is asking how to incorporate privacy-related elements here. That's a really great question, and you know, it's not a simple answer. It's kind of its own session. There's a few different ways you can do this. You know, a consultant likes giving complicated multi-leveled answers, so I'll try and give that a few levels here. Number one is the brute force approach to privacy. We have private information. We want to protect the secrecy of that information, right? Okay, tampering, information disclosure, spoofing, and whatnot. Obviously, real privacy design goes far beyond that. And there are a few approaches to it. One approach that I'm familiar with is called LINDON. I don't remember the exact acronym. It's along the same lines of STRIDE, but for privacy issues, linkability, identifiability, redacted. You know, there's a whole bunch of, you could look that up, and that's its own thing to do privacy modeling, right? And there's a few other approaches that you can include that. When I do a threat modeling session, I'm not doing privacy design per se, but I am absolutely trying to consider that aspect in this, okay? Privacy modeling can often be its own thing, but you never want to ignore the privacy. So during the DFD, you could absolutely identify where you have PII, right? Personally identifiable information, and you can treat that as a protected resource. So at the bare minimum, that's what you need to have and protect that information. But real privacy design needs to go beyond that. You know, the right to be forgotten doesn't get included here at all, right? So you do need to include that. Let's see what else. From Andres Fox. Yeah, okay, I actually answered that about the elevation of privilege card game. Oh, somebody asked about the Linden. Okay, somebody just linked to it. In the chat, Sebastian linked to linden.org. I guess that was a few minutes ago, but I'm a bit behind on the chat, so I'm scrolling down trying to answer everybody. Yeah, okay. Sebastian says, at the end, it is some creative process and no tool or framework can cover everything. And that's correct. You know, there are a bunch of tools, and I'll try and mention this later on. There are a bunch of tools that can help you do threat modeling, okay? I would say it's tool-assisted modeling, and the tool can't do all the work for you. The best tools will take the output of your head or the whiteboard and be able to track that, monitor it, maybe put some automation into that. But again, threat modeling is explicitly a design activity. And just like there's no automation or tool that will do software design for you, but there are tools that will help you do it in a, in a more scalable, repeatable, governanceable way of doing that design. In the same way, threat modeling as a security design, it's going to be the same way. And I will hopefully mention some tools later on. All right. Somebody mentions, Carl is mentioning the OSRU, Open Information Security Risk Universe model by Phil Huggins. I am not familiar with that at all. Carl, you want to maybe drop in and explain a bit about that?
I drop a link into it. Yes, I found it very useful in the sense you mentioned already. It's a high-level framework. It doesn't drag you in a rabbit hole, and we found it very applicable in a large group session just 3 weeks ago. So I wanted to recommend it, and I will drop in the link. I don't want to go into details. I don't want to take too much time. Just a tip for
I appreciate
others.
that.
Thank you. And it's open source, so it's not a company behind it. It's completely open sourced on GitHub.
And we're going to have a session at December about it, I believe.
Sorry?
Really? I didn't know that. Okay. There's a session about it?
Yeah, I think
Oh,
so.
is there?
Yeah, I'll double check, I guess.
I must have missed that. By the way, now would be a good time to point out another great resource on the OWASP Slack. There's a great threat modeling channel. Threat modeling, obviously. If you're really interested in learning more about it, there's some great discussions there. That would be a great question to drop in there because I'm sure people there know about it and are familiar with it. You know, so if you jump into that channel and ask that question, I'm sure you'll get a lot of great feedback on it.
Yeah, thank you. Yeah. Great.
All right. So that's actually interesting. I want to open that link so I don't lose that before it goes away. All right. Let's see if there's any more questions here. Andres, how can I use threat modeling as part of Agile Scrum sprints? Do I also look into this as part of my usual refinement process? Fantastic topic, fantastic set of questions. And I'm definitely going to be answering that, or at least I'm going to give you my answer to it. And I'll tell you right now, every person who does threat modeling has a different approach to this. Okay, I can give you offhand probably 3 or 4 different approaches besides mine, and they're all good. But you know, when we finish the full threat modeling, then the last section is going to talk about how to involve this as part of Agile development and lightweight threat modeling and all that process. All right. So hopefully by the end you'll have a good answer to that question. I'm just going to postpone you by a few minutes. Okay. All right. All right. So let's get back to our slides, and I'm going to go a little bit more. And I was explaining about stride. So we have these, you know, 6 categories of types of attacker goals, so to speak. And by the way, Adam himself says, you know, Adam uses stride a lot, but stride is not going to be, it's generic, right? It's not going to be a perfect fit in every situation. There are absolutely going to be situations that these things do not apply, especially as we get into fields of like IoT and real world, you know, devices in the real world and interactions. And there's going to be a lot of things. I mean, sure, you could shove everything under elevation of privileges, but you want to have a more specific model. And, you know, there's a lot of different approaches, a lot of discussion around different ways of doing this. For most digital systems, this is going to be a really good place to start. And it's going to give you probably, you know, for most systems, almost all threats will be found from something like this. If you do enough brainstorming, you'll come up with almost all threats. Again, there are other approaches, but the way we use this, okay, it's not just a six categories, 6 questions, 6 possible threats. It's not, is there a spoofing threat in the system or not? No. We take each one of these, and we take our DFD. This came from the OWASP site, and an example DFD of some banking system. And you have your different layers here. You have your web server, your application server. It has a messaging bus, right? Maybe JMS, whatever. Reaches the mainframe in the background, like most banks. And what we do is we go through this, and starting probably from the outside, okay, from the least trusted, the external user, and we go through the different levels of trust and trust zones and boundaries. And for each component here, whether it's a process or a data store or an agent or a data flow, especially the data flows, and for each of these elements, we're going to be looking for possible threats. And we're going to use Stride as a guideline or as a brainstorming technique to find additional possible threats. Okay, and you can zoom in or zoom out as much as you want to or need to, right? But the way we're going to use this, for example, we're going to start over here, and let me pull up a laser pointer so you can see where I'm pointing at over here. All right. Okay. Zoom is a bit laggy, but so we could start over here and say, okay, what possible threats do I have on HTTPS requests going into the web server? And we're going to go through Stride. Are there any spoofing threats on HTTPS? And I'm happy for any people to jump in and be more collaborative, because that's what threat modeling is. It's a collaboration. It's a dialogue. Are there possible spoofing threats? And we'll say, well, the user could be spoofed unless he's authenticated, but I can't spoof this web server because HTTPS. And then you start getting into a little bit more detail or an assumption that the web server is actually configured correctly, okay? And you want to be cataloging these assumptions on the side or getting into that detail, but only enough detail as you need to. And then, can I tamper with this request? Is there any way to tamper with this data flow? Again, it depends on how it's defined. SSL could be defined with none algorithm, in which case, yeah, I mean, it'll be easy to bypass. So there's a lot of different ways to ask, and we're going to go through each of the Stride for each of these flows and each of these components, and depending on the amount of time, we're going to get to the back end. Right? We're going to get over here. The application server is sending messages to the messaging bus. All right? Are there any spoofing threats here? Anybody want to jump in with some ideas? No? No ideas? Come on. There's some obvious spoofing threats here. Some non-obvious, but you'd be able to come up with some obvious spoofing threats between the application server sending something to the messaging bus. It might be something like MSMQ, whatever that's called nowadays, or WebSphere MQ, whatever that's called nowadays, JMS, and so on. Is anybody else having a problem with the screen share quality?
The presentation quality is very small, like
It's very weird. I wonder if it's because it's the Zoom issue. I have a big monitor. Honestly, the words here are not that important because it's just a regular diagram. Is it just on this slide or the previous slide also you couldn't see?
No, it's all, the slides are just very small. So I think you have a very high resolution screen.
That could be the problem. All right. So let me, forget that the picture is not that important. Just understanding the diagram.
Yes, it's not
and anything else I'll try and zoom into.
clear.
Sorry? All right, so, it's more about the picture here. While you're doing threat modeling and diagramming, sure, you want to understand what the words are, but I'll often use just sticky notes because they're easier to move around, right, on the whiteboard or labeling. Let me switch to, I actually have a better DFD here that I actually have open. So I mentioned about tools. Number one is diagramming. If you're not all in the same room doing standing in front of a whiteboard, then you're going to need to have some kind of tool for it. I've been using draw.io or diagramming.net. There's a few better online services. I've been experimenting lately with Miro. which a lot of people have been giving great feedback about. I haven't had much use with it yet. But this is a little diagram that DFD that I put together in Dry.io. Are you still not able to see? Let me see that. That is pretty bad. Let's see if I can tell Zoom to do something better.
It is blurry, yes.
Is that a little bit better?
Yes, much
better.
better, much better, yes. What did you do?
Right.
Tell us, please.
Yeah, it is
I
much
had
better.
optimized share for full screen video clip marked. I just removed that.
Great, well done.
So future knowledge, good to know.
Always surf on manual, never on automatic optimization, always manual mode.
Yeah. Yeah, you know, good to know about that about Zoom. Anyway, so here we have, let me remove the Zoom bars, get out of the way so they're not blocking. All right. So here we have in Dry.io, and it's a nice little diagram, and there's nice templates here that you could use to build DFDs. And again, you know, you have the different trust zones, and I prefer it as a zone, so you know inside the zone as opposed to outside, as opposed to just crossing a trust boundary. Okay? And sometimes zones are layered, right? We have the internet, and then we have our data center, and inside the data center we have our DMZ, and we have the different areas, the different servers. So you know, so you have different levels here of how to mark it, how to mark the trust. Now, as you can see, I have a bunch of different data flows flowing here. And one thing that I like about Draw.io is it lets you very easily put in annotations, okay, which would be the equivalent of sticky notes on a whiteboard, okay? Different colored sticky notes. And the advantage of that is that it marks out different things that you don't want to put too much detail in the diagram, but you also don't want to lose that information. You know, as you're discussing it, you want to have that present, so you don't have to keep asking, is that data flow HTTPS? Is it not? You know, so you want to have that detail without cluttering up the diagram. So you notice I have the green C01, and I have down over here a little table, right? And I've marked that out. C01 is TLS, so I know that automatically. C01. I don't need to ask any HTTP related questions because I know it's HTTPS. That's great. C02 over here is authentication, and so on. Okay, so that's one annotation. Another annotation that I have is A for asset or data type. You know, different asset might be a type of a set of data, right? It could be credentials, it could be credit card information, or it could be a different type of asset altogether. It might not be a specific data type. And I can see where that data flows, A5, which is probably credit card details. It flows from the gateway into the API. And this is kind of a sanitized version of a live system that I've seen. So it's very, what did Connor say here? Just saw the chat. Well, I hope this is not, Connor, I hope this is not the most important lesson of the session. But yeah, it's useful for sure. Anyway, so you could see where the data flows, and you could see where it goes. And if A05 is credit card details, it should be really suspicious if this goes someplace else, right? If it gets echoed back to the client, or if it gets sent to a third party. I would be really suspicious about that asset going somewhere. And so simply by visualizing it, the way the system works and the way the flows work, it sometimes helps you float up possible whether they're threats or even accidental threats. Okay. The last thing that I have annotated here are the red TA, threat agent or threat actors, which is very useful to understand if we're talking about a specific threat or specific type of attack. who are the users or the entities that might be doing this? Because that matters a lot. If your threat agent for a specific threat is only an internal admin, then obviously that's going to change the picture if it's an anonymous user over the internet. And the same attack could be very, very different. So you understand the requirements and the constraints of that attacker. Great. So you can use this, and again, you go through each component and ask questions around that. You know, what threats do I have here? If I can bypass it, can I send requests directly to that? Can I spoof identity? And now I'm going to try going back to the PowerPoint. You can see that a little bit better now, right?
It's much better.
Yes, better.
Shocking behavior. Shocking. Maybe Zoom is encrypting it too much. I don't know. So yeah, so you could now go back and actually start asking questions on each of these components, and that's really what threat modeling is: asking questions. You know, some people like being the devil's advocate. Right now, we're being the advocate for supposedly for the attackers. Like, what possibly could go wrong? What could the attacker do here? So if I'm looking here now, I have the application server sending a message into the messaging bus. Now I can start asking questions around stride. For example, what kind of spoofing threats could there be here? Well, the application server is sending to the messaging bus. If I am internal to the network, then I can spoof the application server and send a fake message to the messaging bus. But I could also spoof the messaging service, the messaging queue also, and basically intercept all these messages from the application server. Okay. Are there any tampering threats here? Well, obviously, if the protocol isn't encrypted, and most aren't, you can change that en route. You, of course, would need to be in that protect section of the network if it's good, and that narrows down who the hacker could possibly be, assuming your infrastructure is done properly. Okay. Tampering, repudiation, and you start asking all these different questions around it. Repudiation, you go through, so again, you go through each of these components and you ask those questions. Sometimes you need to flesh out more detail, and that's what's great with the annotations that I showed in IO, or you might be wanting to put sticky notes on the whiteboard, right? Or maybe what you need to be doing, hang on, I see my video is lagging. Let me try and speed that up. So Zoom is sucking up a lot of power. Let's try and kill the browser. That might help. Okay, hopefully that will do something. So you go through each of these components and you ask each of those questions and you find all those things. As you flesh out possible information, you might be putting a sticky note on the whiteboard, or you might be annotating the diagram itself, right? Or maybe you're just keeping a running list in a Word document on the side of all the assumptions that you might be floating up. And you're going to have all these questions that, oh, I don't actually know how that works. I developed it, but I don't remember. I have to go check. Or the person who developed it isn't in the room, or there's some configuration. And you might have a bunch of assumptions that you need to go check afterwards. Okay. Now, as I mentioned, you might be using DFDs if that's what you have, or you want to build that up lightweight. But you could just as well use other diagrams. Use a logical process diagram that can work. You know, I've seen it done on swim lanes. You know, whatever you have, whatever works, whatever lets you understand the way the system works, the interaction between the components. Preferably a focus on flows of data, because you know that's the way most attacks are done, by sending some request in some way. And you know, so whatever you're using is fine. I'm going to try and shut the background off, see if that makes it better. Is the sound still okay? Are you still hearing me okay? Because I noticed the bandwidth seems to have been a problem.
Sound
Okay.
is fine.
Great. So whatever diagram you're using, again, you want to have something visual. If you have nothing, put together a DFD. Should be quick and easy. Another approach to doing this, it's both another semi-visualization technique, another way of floating out additional threats, and it's kind of a different approach, is what's called attack trees. By the way, Grow.io has a nice stencil for attack trees also. Okay. What an attack tree is, basically you put on the top basically the root of the attacker goal, the logical goal that the attacker is trying to reach. For example, the attacker is trying to read another user's messages in some kind of messaging system. And then you have a lot of different ways to get to that goal. It might be vulnerabilities, it might be vectors of attack to be able to get that logical goal. And part of what might see my system lagging, I'm going to try and figure out what's doing it besides Zoom. Zoom is sucking up a lot of resources, but no, it's just Zoom. Shouldn't be any other problem. All right, let's hope it works good for now. So you have basically mapping out possible branches, vectors of attack, in order to achieve that goal. For example, maybe the user didn't log off of a shared computer or internet cafe, whatever, right? Maybe they left their device open and unlocked. Maybe SQL injection, right? Or maybe authorization bypass, and so on. And for each of those vectors, there should be a mitigation or a control in place to prevent that, right? SQL injection, you need data validation and control planes and parameterized queries and so on. So, this isn't authoritative, but you want to have that. Authorization might fail, then you want to make sure that you have authorization checks. You're worried about the browser cache, that's a vector. You put in you make sure you're not caching it. And then it's really easy to see that, oh, I have over here a vector on the left, there's a branch here that doesn't actually have a control leaf. And that's where you need to know that, okay, I'm not going to worry about testing SQL injection. I mean, sure, it needs to be checked besides that. But if I'm worried about reading other users' messages, what I need to do right now is fix this vector. I need to put a control on that. And this is also really useful, by the way, for penetration testers or QA. You come in and say, okay, I'm not going to try and I'm not going to try all the possible vectors. I have my vectors laid out. I know which controls there are on those vectors. So I'm either going to try and validate those controls or try and find some ways to bypass them. I don't need to waste time trying to test this vector that doesn't have any control because I know it from the design, there's no prevention from that. So that saves a lot of effort. Now, the thing about attack trees is that they are kind of heavyweight. So this whole tree is one single set of thread, right? There's a lot of vectors to be able to get there. It is good if you want to, flesh out a lot of variations on different vectors to be able to achieve that. So there are a lot of different approaches that you really need to care about. Then it might be worth putting this together. But it is kind of heavyweight, so it's not something that I say that every developer should be doing this for every user feature, for every feature. But it is something that is worthwhile being familiar with. It does get used often in a lot of heavier methodologies. And what I find that it becomes a lot more useful is when you focus the attack tree on how the attacker goals affects your value, your business goals, okay? Whatever those goals are. If you have requirements, for example, messages need to be confidential, then that needs to be explicitly there. Yes, might be able to read other users' messages. That can also now affect my goal. There should be another leaf there, or be explicit there. And if you can trace every branch of the attack tree back to your value, your requirements, that will already help a lot. Bring this back into a lot of value when you're trying to define which features you need to do, because you know why. I see some questions here. does it make sense to combine data flow models with attack trees? So create attack trees for possible threats found in the DFD. Yeah, absolutely. I mean, it doesn't make sense to build an attack tree before you understand how the system works, right? So the DFD is a representation of the system. Attack trees are a representation of a complex attack, okay? So this is a very simplistic attack tree. Very often you'll have a few more layers. Sometimes an attack requires a few different vectors. For example, first I'm going to do a skill injection to steal your password, okay? Then first I'm going to do a skill injection. Then I'll be able to steal your password. Then I'll be able to log in as you, okay? And there's a lot of different vectors, a lot of different attack techniques that the attacker would need to be able to do to exploit in order to reach their final goal. And don't forget, these messages are encrypted, so how do I get to the encryption key? So you need a lot of, the tree might be a lot deeper. But this is a representation of the attack, not the system. That's what the DFD is for. And again, I say, when you model the attack, you want to see how that attack affects you. It doesn't need to be just from the attacker perspective. At some point, you want to bring it back to you. Does that make sense, Andres? And again, I want to elaborate just a little bit on the last point. Again, you're going to model the system in DFD. You can use something like Stride to float up possible threats. And if you want to get into more detail, you want to flesh out all the possible variants or maybe all the vectors for a specific attack that you might have found either using Stride or any other technique, then attack trees helps you take that one simplistic attack, brute force attack on an internal system, and all of a sudden you need a lot more steps on that way. Okay, excellent. Another methodology, which is more in the heavyweight formal category, it's a risk-based methodology. It's called Process for Attack Simulation and Threat Analysis, or PASTA. You know, it might be lunchtime where you're at. I don't know. Tony UV is one of the fellows that created this, and it's a really interesting model because it's the folks in governance here might be more interested in this because it's more formal, right? It takes those 4 steps that I was talking about and breaks it out to 7 steps. Okay, and each of those steps, there's a few different activities that you need to do, right? And you have all that steps, and each of those steps might be broken down. So first you need to define the objectives and the technical scope, and this was just a pre-step for me. And each one of those has 3 different tasks that you need to be able to do to be very explicit and document that. And then application decomposition now breaks this down to use cases and actors and DFDs and trust and a whole lot more detail. And it requires a whole lot more threat intel and a lot more data and statistics. And it's based on, and it gets to the point where this is probably one of the best, most correct threat models you can get because it so relies on so much information. Okay, but as I said, it's a bit heavyweight. Now, this is not something, you know, this is probably great for governance folks, right? It's great for CISOs and risk managers. But if going back to one of the earlier questions that somebody asked, okay, how am I going to do this as part of my agile development for each user story? And the simple answer is you're probably not. And here's where I'm going to jump in and talk about, hang on, now Zoom is blocking because it's not defined. Here's what we're going to talk about the perspective of developers, right? Because, hang on a second, Zoom is acting up. Because these approaches are great for security teams. It's something I enjoy doing. There's a lot of people that are really, really good at it. But if you want more people to be doing this, and we want more people to be doing it, we want developers to be doing this, we want the security champion to be doing this on every sprint, and you're not going to be able to get that level of depth. Okay. Dance monkey boy. Okay, so let's talk about, and now we're getting to the point we're going to talk about how to do this as part of the development workflow. And first I want to talk about, and I freely lifted this from one of my conference talks, we're going to talk about some of the challenges or issues that a developer team might find when they try and implement these methodologies, whether it's pasta or stride per element and do a full stride matrix and all that. And we're going to talk about, some of you might have already heard me talk about this. We're going to talk a little bit about some of the challenges. Number one, right, it takes too much time. Building out a full stride matrix for, on every component for every feature could possibly take days, right? Right, especially if you have an expert that is trying to be comprehensive and is trying not to forget anything, right? I think what Sebastian was saying, you don't want to miss anything, and they want all those nuances and all those variants and being able to find all those things, right? Yeah, you don't got time in a 2-week sprint to be able to do that. I'm sure you've heard security is everybody's job, and it is everybody's responsibility. But you know, if I'm a developer, my job is to write code. It's to develop features. It's to push a new version that will get more users or get more funds or whatever it is. And nobody pays for security. You might pay for a security product, but you know, if I'm signing up for a subscription for cat pictures, I don't really care if those cat pictures are secure or not. I'm actually more of a dog person. You might have heard this one, think like an attacker. Right? The problem with that, as again, as Adam says, it's not really actionable. It doesn't really give any proper advice to developers, and you don't really know, doesn't really help you model anything better. Think like an attacker, that's like saying, think like a chef, I like to say. That's not going to help me bake a better cake, right? It's not going to make me magically learn how to make soup. So think like an attacker doesn't actually help very much when you're trying to developers to do threat modeling. It doesn't get them anywhere. And then there's the approach that says, well, we know about all the threats. We're building a banking system. Obviously, people want to steal money. What are you wasting time modeling for, right? Same thing as always. They want to break in and steal money. And then there's the problem that, you know, most of these approaches are kind of waterfallish, right? Very few developer teams still work that way. I mean, some do. Sometimes they need that. But it's kind of a mismatch. It doesn't really fit the workflow. If you're trying to do a stride approach or pasta on the entire design, we don't have the entire design yet, right? We're doing a more lightweight user story. We only know each user story as we go. Does this make sense? Does this sound echoing to people? And then there's the problem that, you know, you can't do a big model up front if you don't have a big design up front, right? You have to squeeze yourself into a hole you're not going to get out of. And you're trying to force it to something that doesn't exist. And then there's all the nice documentation that you get from threat modeling, right? But that's not part of the design documentation. So when you're reading a design, you don't necessarily have that information of why I'm building this control and not that control, and so on. And we like to keep that together. And because it's separate, very often the user story, the feature design will change, and the threat modeling hasn't. The threat modeling is now out of date. And you get a long list of, you know, I've seen threat models of hundreds of threats, and it's not actionable. If anybody here is a developer, you know, if it's not in your backlog, if it's not in Jira, I'm not fixing it. It doesn't exist. I won't do anything with documentation. I love Chang. And then there's the problem that we're spending a lot of time modeling threats that are unrealistic. Sure, threat modeling still helps you not implement protections against threats that are not realistic, but you're still spending time thinking about all these possible threats that just don't really matter. You know, it's not Hollywood. And, you know, developers have a completely different mindset from classic InfoSec people, right? Developer stallions, they want to run forward, they want to develop features as fast as they can. Developer velocity, 2 weeks. Security people like to rip things apart. So if the developers are waiting for the security people to come back with a threat model, that's friction. I hate it. It doesn't work. It's not productive. And then, of course, there's the problem that the security people come. The main security team drops in every couple of months and tell me what you're working on the past 3 months. Tell me everything. And, they're not part of the team. Again, it doesn't have to be that way. The full-size threat modeling might be done by a security champion on every team. This is just a very common model that happens often. It might be external consultants to bring in that expertise. And part of the reason is because there's not enough security people. Statistics, last time I saw, I think it was for every 100 developers, there are 10 QA people and only 1 security person. All right, that's a whole lot of code being written and not a lot of security people doing it. Security doesn't scale. Basically what I'm saying, it comes back to the fact that I don't want just the security team doing threat modeling, but anytime developers are writing code or developing features or fleshing out a user story, there needs to be some threat model activity taking place. And to do that, it can't be a full-size stride matrix. It doesn't work that way. You don't have time. You spend what, 30 minutes, 2 hours doing a full user story, fleshing it out, maybe not even, maybe it's just a few minutes. You don't have time for stride. All right, thanks, I'll get right on that. The problem is that, we're stuck paddling upstream. You're spending a whole lot of effort going in the wrong direction. So I like being efficient. I like making sure that we're using the right tool for things and making sure that we're not just pedaling really, really hard instead of just getting something that works more efficiently. All right. So this comes back to what I was saying about my value-driven process. And again, it has a lot to do with how we get developers to do this as part of their workflow, right? So when I talk about a value-driven approach, and again, we talked about classic threat modeling, and that's, when people talk about threat modeling, that's typically what we're talking about. Now, the past few years, a lot of people have been trying to find different ways to get that value from threat modeling, to get that end result wrapped in together with lightweight development workflows, Agile, CI/CD, DevOps, whatever it is, and get that involved. And there are a few different approaches. There's Izar's threat model every story. There's Irene's incremental threat modeling. There's a few others. And I wanted to show an even more lightweight approach. I call this value-driven. And again, it comes back to all threat models are wrong, some are useful. Because the focus here is that I'm going to assume that whatever threat model I build, it's going to be wrong. And if it's going to be wrong, I need to be okay with that. And if I'm okay with the threat model being wrong, that means I don't need to worry about finding everything. I want to focus on what brings value to the product. Okay? And what brings value to the product? Better security features, or more security features. Only the things that are useful for your product in your context would actually add to the bottom line or protects the bottom line that you have. Now, I've been talking about value chain a lot, and I'm sure Dennis will jump in and say, oh, this actually connects nicely with Wardley maps. And yeah, it does. So number one, focus on why are we building this? Why are we building this user story or this feature and not some other thing? Why does this get priority in the backlog? And it comes back to either user needs or protecting, providing a new feature, getting more eyeballs on my cat pictures. Honestly, I'm a dog person, don't tell anybody. Getting more eyeballs or selling more product or whatever it is, there's usually some business reason or a user need for this feature. Sometimes it's obvious, sometimes it's implicit. I want to be explicit about it because I promise you, not all developers are fully aware of it. Not all designers, not all product managers are fully aware of it. Not everybody that architects or designs a user story fully understands the purpose and the goal of this feature and this user story. Once we have the why we're building it, the user need, then we need to understand the process, the logical flow from how this feature actually provides that need. Okay, and if we understand what our goal is and how the system provides that goal, now we can simply answer, how do we protect that flow? How do we ensure that we actually get that goal, as opposed to the flow being built, but some malicious user sidestepping that goal and getting something else and abusing your system, basically violating your goals. Okay, so it comes back to basically starting with the user goal or the business need, understanding how I achieve that, and protecting that. So what I'm talking about now is actually kind of more not worrying about all the possible attacks that could possibly be, but just putting guardrails up on your happy path. Okay, putting guardrails on from the way the system works, from what the user experience, to whatever your business goal actually is from that. And I talk about finding the value, right? It's usually follow the money, right? You sell more products or more features. I want to run a juice shop. I want to sell juice. Follow the money. I understand where that value comes from. Sometimes it's how do people die if you're flying an airplane, right? Or it's a hospital management service. There's other types of value. Maybe I just want eyeballs on my cat gifts. Okay. So now I'm going to talk about lightweight threat modeling. And again, there's a few different approaches. This is mine. There are many like it. This is my own. So again, I'm focusing on the value chain. And that goes back to the user needs or the business goals, and understanding how I get to that value and the entire value chain leading to it. Usefulness, focus on what is useful. If there are controls that by the book, you should do it. It is the best practice. Everybody says it. OS cheat sheets say you need to be doing this, but it's not necessarily useful in your context. Then choose something that is more useful. Choose something that has more value, that pushes up the value chain to the user to protect that value, that happy path. Again, you're building mitigations. You have a limited amount of time that you can spend building unsellable security features. Focus on your goals, on the business goals of those features, of those user stories. And you might get to the point where you might have additional goals that are security related, because maybe you get your customer to upgrade. Zoom was talking about the free version. We're not going to, you want encryption, you got to move to the commercial paid version. I mean, it makes sense from a business sense. I'm not going to argue the ethics on that right now. But that's an example of a security feature here that adds to their business goal. Okay? Use threat patterns libraries. There's a few, OWASP has the Cloud Security Project. There's the Threat Modeling Cookbook. There's a few commercial products that include this also automatically. Given a specific architecture, you'll know the automatic set of threats and mitigations that go along with that at a technical level. Because the technical level usually is rather, I won't say boring, but rather the same. And you could copy paste these patterns a lot, right? I want us to focus more on the business aspect, the business threats. And it's what I call assumptionless design. Okay, I mentioned assumptions before. As you're designing the system or as you're drawing the DFD, the data flow diagram, you want to make darn sure that there's no hidden assumptions here. You want to be able to float that out. I like using Socratic questioning. Okay, there's a few different approaches. It's an approach to be able to float out hidden assumptions, whether it's for yourself or for others that are explaining the design, right? So if I have one person standing by the whiteboard drawing the diagram, everybody else should be asking these questions. Is that really work the way you expect it to? What actually happens there? Tell me more details. And there should be no assumptions in this design, or rather, I should say, no implicit assumptions. If they're explicit, you write them down, you can either validate that, you can check it out, you can put a control in for that. And it's not really an assumption per se. It's an assumption until you actually check that out. And the scope, when we do this is the when. Every user story or every feature or every epic, wherever it makes sense according to your workflow, it's basically whenever you're building out that fleshing out that minimal design, they call it just enough design. I want to have just enough threat model in there, right? There needs to be a little bit of aspect of the threat model, the security. Again, how do I ensure that I get those goals that I'm trying to achieve, right? In, again, wherever you're having your design, whether it's a user story, feature, epic, and so on. It might be during discovery, once a sprint, once every so often. And the threat model should not be its own thing. I want threat modeling to go away. I want that to be part of the security, part of the design. Security design is design. Okay, so I include that as part of the user story. Okay, and the workflow now becomes really simple because I'm not adding a lot of extra work that you haven't been doing or shouldn't have been doing until now anyway. I'm talking more towards the developers and the product managers in the room. So number one, the user story needs to be explicit about the goals. Why am I building this user story? What am I trying to achieve? What is the bottom line? And understanding the value chain of your flow, right? And you need to, normally most user stories describe the happy path, the expected flow. Now I also want us to be more explicit about the unhappy path. What is supposed to happen when you don't meet these expectations and assumptions, okay? You need to float out all these assumptions that you normally have and you assume that everybody understands correctly. And any developer will tell you that when they read the description, there's a lot more detail that needs to be fleshed out because not everybody understands it the same way. So if you are explicit about if you know about your assumptions, you can be explicit about them. You can then validate them. Again, either in code or go check that out or some kind of script in an automated way, whatever it is. Any kind of conditions you have on those happy paths, you can now enforce it. Again, it's a simple check in code if you're on the happy path or you fall down to the very well-defined unhappy path. And you're explicitly going to handle that. Okay? So there's not really anything here that shouldn't have already been in the user story, but because we're now putting guardrails up on that happy path and the unhappy path, we're now going to be preventing a lot. And it's true at this point, we're not going to be generating a whole long list of threats. We're just going to be explicit about what we're actually protecting. It's actually getting later, so I just wanted to give a quick example of what I mean by a value-driven approach. I like using the juice shop as my own personal victim. If you're not familiar with it, it's a great OS project. I have a vulnerable website. Best place to never buy juice online. Okay, you buy your banana juice because you got to feed your monkeys. Modern architecture, more or less. You got your Node.js, you got your SQLite, you got your Angular. And honestly, you don't always need more detail than this at the architecture level. We want to focus on the user story. To be clear, we're not talking right now about architecture threat modeling. That still needs to be done. That's its own thing. And that's usually not the problem. The problem is the ongoing user stories that we don't have the security consultant working with us all the time, and we don't have time to be doing all this. So I'm talking about the specific user stories. Now we introduced a feature here. As you go to checkout, you can put on a coupon. They publicize it once in a while on Twitter or Facebook, and you can get a discount, right? You can get a 30% discount. Now the real question here is, okay, why am I developing this feature? And usually when I ask people, okay, why am I developing this feature? And the answer is to get cheaper juice. And that is the absolutely incorrect answer. That is not why I'm developing this feature. Correct? Anybody want to jump in real quick? The reason I'm developing this feature of this coupon discount is clearly and obviously marketing, to drive more sales, to get new users, new customers. The customers I already have are happy paying my full price. That's not a problem. Sure, give them a benefit once in a while, give them a perk. And I can afford the 30% because my margins are high enough, right? But it is absolutely, as Andrea says, it's about selling more juice. And more importantly, it's about getting residual returning customers. In other words, this is going to be part of a marketing effort. I want to get, let's say, 20% new customers that I didn't have, and half of those will continue buying at full price. So our goal here is those 10% returning customers. That's what I really care about. Now, when you understand it in that context, then you say, hang on a second. So it's really all about the user experience, isn't it? So if using the coupon creates a really bad experience, you have to, I don't know, every time I put the coupon in, your session crashes, that's pretty bad. If I put in this coupon, create a coupon, and I publicize a forged coupon code, it'll to paying instead of 70%, they'll be paying 200%. They go in, they're not going to buy that at twice the price, and that's going to cause those customers to never ever come back, right? And yeah, so if you just look at the coupon code, I'm going to try fuzzing that. Can I make it 60%? Can I make it 90%? Can I make it 120% discount? Could I make it be valid long after the date? And those are kind of obvious almost, but I'm looking for the business aspect of I'm trying to drive more sales. I want returning customers. I want to keep those returning customers. And when that's my focus, now I understand there's a whole bunch of other threats that I should be looking at. And this is not something that you need a security expert to be doing either. This is something that very much is driven by the business, very much is focused on the business value, the business goals. So let's talk about some techniques real quick. You understand the logical approach. I want to just give some quick, a few minutes of some techniques. The thing about Agile is that there are some challenges for security people, but there are definitely some advantages. Number one, cross-functional teams. Okay, this is something that's inherent in the Agile Manifesto. This is something when you're doing threat modeling right, you're already talking about cross-functional teams. I remember, was it 15, 16 years ago, I was doing threat modeling at Microsoft, one of the Microsoft teams, and we didn't call it cross-functional teams, but we absolutely said all the stakeholders need to be in the room. You need your developer lead, you need your QA, you need your architect, you need a security person, you need a business person, and you need all those perspectives to be able to do proper threat modeling. It just makes sense as part of the Agile flow. Focus on usable software, usable controls, usable security. Unusable security isn't. Whereas my own personal rule, I like to say, security at the expense of usability comes at the expense of security. Let that sink in. Because we don't care that much about security controls that don't add to the flow. That's not usable. Again, all threat models are wrong. Some are useful. Focus on useful controls. And because developer independence is both a challenge and a benefit. If they have the space to go and build security, and we give them the tools and the platform and the techniques, we can rely on them to do it. Sure, we still need governance and we still need control. We still need code reviews and pen tests, but we get a better baseline of them developing more secure features to begin with. And then there's a few activities that teams that work with an Agile workflow usually have. They have definition of done, which I'll show in a moment how to include that in security, acceptance criteria, test-driven development, right? Built-in unit tests, regression testing, automated testing, and all that stuff. So this is something that actually came up, I think it was 2 years ago at the summit. So a bunch of us were sitting in a room and we're trying to find the most minimal expression of a threat model that we could possibly come up with that echoes the way Agile works. And somebody said, I want something as simple as a user, I want so that. As a customer, I want to purchase juice so that my kids let me sleep in. And somebody came up, I don't remember if it was Jim or Fraser, one of the folks in the room, came up with without. It's just a simple little clause that we're adding at the end of the user story format, without. Without my credit card being stolen. Now, as you can see, there's zero detail there, okay? And, as we were discussing this in the summit, I don't know if it was 2 or 3 years ago, as we were discussing this in the summit, we realized this is really powerful because, you know, the user story description doesn't have a lot of detail already there anyway. You know, it's an invitation to a conversation. You want to go and flesh those details out later as you go, right? It's just kind of a title, and you understand like a top line description of what the discussion needs to produce. And we're basically sticking a flag in that, and we're saying, here's a little bit of security that that you need to pay attention to, without my credit card being stolen. And you can go and flesh that out. And simply by doing this, it just plugs that directly into the workflow. Acceptance criteria is something that they always define on user story already anyway. So I want acceptance criteria for security requirements. When I log in with the wrong password, I should be locked out after a certain number of times. That's an acceptance criteria, which I can now turn into a security unit test, right? Test that accounts are locked after X number of attempts. And its corollary should be test that locked accounts are automatically unlocked after a Y amount of time. And then there's abuser stories, which are very similar to user stories, but from the perspective of the abuser or the attacker. Sometimes they call this evil use cases. Okay. So as an attacker, I want to impersonate another user so that I can steal their juice box or their credit card, right? So this helps me flesh out some more detail if I want to build a more complicated control, gives me some more information, some more context to be able to put this into the backflow so that, you know, gets managed just like any other feature. And one detail I would put here is that it's very important to always take the abuser story or the attacker story and draw that back to your original value, right? The value driven here, the business goal, or whatever kind of user need you have here. My user need is to get juice, right? Without their credit card being stolen. So the abuser story needs to correlate with that. And this is kind of more of a user story version of attack trees. And this is something that I started introducing and really resonated with a lot of people that I call story points. This actually happened accidentally. Don't hear so well. Somebody's talking to me about story points, and I heard story points. That sounds interesting. Tell me about that. So it actually works out really well, and it's the same idea as story points, which is a really rough estimate of how much work this story would be to implement compared to other stories, right? It's not how much work it is. It's not how long it will take. It's just relative to other stories. Sometimes it gets measured in t-shirt sizes, right? This is a small story. That's a medium story. That one's an extra large story. Maybe we should break it down to a few smaller stories. Or Fibonacci values, you know, 2, 3, 5, 8, 13, 21, and so on. In the same way, the same idea is story points. How possibly bad could this story be if it explodes in my face? If everything goes sideways and everything goes the exact wrong way and the users are constantly falling off the happy path, how possibly bad could this be? Is this a small amount of sorry? How sorry will I be? Is this an extra large sorry? And then based on your sorry points, or sometimes you want to do this on dot voting to decide which stories you're going to work on. Right? You have a limited amount of time. You want to time box it, and I have 90 minutes to do a threat model. Which story should I be threat modeling? You can do dot voting, which is another agile technique. So based on sorry points, you decide either which story to prioritize or how much work to do on it. For example, if it's a small sorry point, maybe I can, as the developer, I'll just go and do a simple without clause myself. If it's an extra large sorry points on this feature, then I should probably get the security team or call it an external consultant to do a full stride matrix or pasta. Okay, so this is kind of an escalation metric here that's very intuitive, and it actually works really surprisingly well even. And yeah, it's not going to be accurate, it's not risk, it's not an exact amount, but it gives you a quick thumb to the wind indication of where I should be working, spending more. So it's, yeah. The other thing I want to show is definition of done. It's part of the process of defining what needs to go into a user story, right? And it's very easy to say, you know, if the team agrees, we change the definition of done to include every user story needs to have a threat model and security tests. Just as an example, you can change it however you want. And this could be adaptive based on story points. Higher story points need a stride matrix, lower story points might not. You can build a definition of done that makes sense for your team, and now that's part of the process, and now everybody will agree and work on that. The last thing I want to point out before I wrap up and take some more questions, I see. I like that story points actually reduce achieve story points if you do things really wrong. I'm not sure, Andreas, I'm not sure I understood that correctly. Andreas, can you elaborate on what you mean about achieve story points here? You can feel free to unmute if you want to jump in, if it's easier or not.
Yeah, I just meant story points. I'm Andreas, hello.
Hi.
I just meant story points are a good indicator how bad your quality is, for example, in regards to security controls you have implemented and stuff like that. So that's what so it minuses out your achieved story points somehow.
So it's kind of really parallel to story points. What it does is it saves you from spending time, extra time doing a full stride matrix on a story you don't need, or it helps you realize where you do need to, right? So it's not really, it doesn't really correlate with amount of work like story points does, but it helps you focus where you need to be spending more time. So overall, you might be, might save you work, right? Because you don't need to be wasting time on things you don't need, right? But yeah, I mean, does that answer your question if I understood you correctly?
Yes, yeah, exactly. Okay, thanks.
Okay. So the last thing I want to add in before I wrap up is that this value-driven approach will help clarify a technical issue or a technical attack into a business threat that makes sense. For example, if you come to you know, senior management and say, well, we have a cross-site request forgery on our site, you know, if you're building bank software, the business is going to say, what are you talking about? Go back and build some software. Go write some code. But if you translate that to a business goal, a business value, unauthenticated access to cash transfer, heck, that's going to get fixed. You're going to go ahead and spend some time and effort to fix that. And this helps translate basically any technical thing. Stored XSS, oh, they're going to say that, yeah, that violates our coding practice, our policy, and that's not compliant. That has to be fixed. And you come back 2 years later and they haven't actually fixed it. But if you change that language into, I can take over an administrator account, again, that's going to get some attention. Instead of authorization bypass, we tell the juice shop, oh, I could get all of your juice shipments to come to my house, and you're not actually, your customers aren't actually getting juice. Again, that's going to get some more attention than something generic and technical and not interesting. Denial of service. Bring it back to what actually matters to the business, the goals, the value. And that in a nutshell is what I call value-driven threat modeling. So let me wrap up real quick and then I'll take some more questions if you need. Threat modeling allows you to design for security. That's what it is. That's how you do it. If you want a secure design, you need to be doing threat modeling. Everything needs to be threat modeling. It needs to be threat modeled. Every piece of software, again, at different levels. I'm not saying you need to do a full pasta for your catalog, but there needs to be some consideration to security. Am I doing it right? Do I need to be doing more? Who should be doing it? Really everybody, not just the security team, developers, DevOps, whatever kind of software, whatever your part in building the software the product is, your product manager, whatever it is, you need to be doing some element of threat modeling. And sometimes it's just on the business goals aspect. And again, coming back, focusing on what is most useful, most valuable is the business value. And focus on usefulness. All right? So that's threat modeling really in a nutshell, with a few different aspects. Andreas, I hope I really answered your earlier question of how to do this as part of an Agile workflow. I hope this makes sense for you folks. Yeah, I can take more questions now if anybody wants.
All right,
Our
everyone.
time's about up.
Anybody who has questions, please don't be shy. Ask as many questions as you can, as you want to.
All right. I mean, our time's wrapped up, so thanks for joining me. I don't mind staying on longer if anybody wants to discuss or ask any questions. But I'll let the rest of you get back. So thanks a lot for joining. I hope this was useful for a lot of you. I hope you get a better idea of what threat modeling is, and hopefully I convinced you a lot to spend more time learning more about how to actually do this. I mean, again, this is just what it is, and how to do it. It's you do need to experiment. And I will say one more thing. The hardest threat model is the first one. Okay, the hardest threat model is the first one. So I'm basically saying, just get started, do it wrong. All models are wrong, it's fine, accept that.
Mhm.
But then you'll get to the second one and the third one, and eventually it might actually be good and useful. Okay, and that's the point. Don't be scared of not doing it complete. Remember, all threat models are wrong. It's okay that you're going to get it wrong. What matters is that you get value out of it. And it doesn't matter what methodology or what tool you use. There's definitely more useful than the other ones. But anything that you find that works for you, that's good enough.
All right.
All right,
I do have a question.
go for it.
I mean, it may be a very noobish question. I apologize for that in advance.
This is a newbie session, so I'm fine with that. Go ahead.
Yeah. Have you, so threat models are something you do proactively to try and figure things out. How do you incorporate them post-incident? Like, I'm sure if incidents happen or issues happen, then in your experience, what's the best approaches? Things like you have to have a feedback loop back to your threat models. And I was just wondering if you could share any experience or any thoughts around, after the fact that if something's gone wrong, what's things that you found that people should do with their threat models?
Yeah, so as I understand, you're actually asking two different questions, or maybe you only asked one of them and I understood both. Number one is threat modeling an incident, which to my mind, if you understand what happened in the incident, you don't need to be threat modeling that. I mean, you have the information, hopefully you have logs, hopefully you know what actually happened. But the feedback loop is very interesting and very important there. Because let's say you built out and you threat model your whole system and everything is good and everything is fine and everything is fixed. And then an incident happens, you get attacked and breached and whatever. Now you have to ask yourself is, how did that even happen? If I did threat modeling, I should have been secure. Well, there's obviously never a good, there's never 100% guarantee that you're going to be secure. So get that out of the way. But then the question is, okay, so how do I make sure that A, this is fixed completely, and B, how do I fix my process so that next time this won't happen? So you have to take it back. And number one, you can now compare that to whatever your threat model is. Okay, were they able to exploit a part of the system that wasn't in your DFD? Number one. Number two, did they find an assumption that you didn't realize? This is also very common, right? Did they find, you assume, you set up an S3 bucket, you assume it's going to be secure, you don't take into account that by default it's open to the world. Assumptions. So did they find a new part that you didn't know about? Did they find an assumption that you didn't deal with? Did they exploit a threat that you did identify, but nobody fixed? That's also possible. Now, in that case, it might be simply a question of, we decided the damage is not worth fixing it because it's too complicated. We're not going to do it, and that's okay because you accept risk. You might want to reevaluate that, but you accepted that. Or it might be simply a question of, we didn't evaluate the risk of this threat correctly. And we thought that it's going to be a nuisance attack, and actually they managed to use that nuisance to be able to steal, I don't know, $1 million, right? So now you have to understand what went wrong in your threat modeling, if something went wrong. Again, just because they found a way to exploit your system doesn't mean there was something wrong in your threat model, right? All threat models are wrong, right? But it might be that you did identify it or you ignored it on purpose, which might have been the right decision at the time, okay? Now, if it's something that in a component that you know about and there's no assumption, you just ignored the threat, then it might be a question of possibly lacking expertise, lacking experience. Maybe it was the first threat model that we built and we didn't know what we were doing. So we might want to revisit that threat model and do it again now that we have a couple of years of experience under our belt. Okay, so that feedback loop is important, and this goes back to that step 4 of, you know, did we do a good job and analyze the result? It's just, you know, longer term, further downstream. Does that make sense to you?
Yeah, thanks. Yeah, that completely does.
Great.
All right. Great.
All right, thanks a lot, everybody. Appreciate you joining me. You know, check out the threat modeling sessions at the summit next week.
All right. Thank you so much, Avi. And thank you guys for attending this session. I'm going to end the recording now. Have a great day, everyone.
Thanks a lot, everybody.
Bye-bye.
Bye.